This question is on the safety features of our electrical circuits. So in part A, you are supposed to explain why we put the switch on wire A. So you must know that we put the switch on the live wire. So this is the reason. The switch is connected to the live terminal in the plug so that we can disconnect the appliance from the high potential of the live terminal. This means that when we switch off the circuit, the appliance, or when you switch off the switch, the appliance will be at 0 volts potential. In B part 1, explain the purpose and the action of a fuse. So the fuse is used to protect the electrical circuit from overheating. So whenever there's more current, higher current than the normal operating current, this is probably due to electrical fault or some issues with the circuit. When there's a higher current, the fuse will burn, and this therefore breaks the whole circuit, stopping the current from flowing. In B part 2, when wire A touches the metal case, when a person touches the case, the person will not be electrocuted. This is the reason why we have earthing wire to protect the operators, the humans using the appliance. Now, even when there's a leakage of current, or when there's, well, like in this case, the live wire touches the metal casing because perhaps the insulation is frayed off, what happens is the earthing connection. The earthing connection is always connected to the casing, the metal casing of the appliance. In this case, wire C is touching the metal casing. That is the earthing wire. This earthing wire will direct the current through itself to the earth instead of having the current passing through the person's hand via the person to the ground. So this is the function of the earthing wire to draw the current to the ground. Now, if there's no earthing wire, then the current will pass through the person's hand when the person touches it to the ground. This will electrocute the person. Now, because wire C, the earthing wire, has a lower resistance than the human body, that's why even when we touch the faulty appliance, that there will still be a short circuit. All the current will pass through the earthing wire. No current will pass through the human. So this is how an earthing wire protects the user from an electric shock when there's some faulty when there's a fault within the circuit itself. One last safety feature is double insulation. So double insulation means that the electric cable is insulated from the internal circuitry. So in addition, the components within the circuit is also insulated from the casing of the lamp. So it's double protection, double insulation. For example, in a typical wire, the wire that we see, the power cable that we see, usually the white or the black one, that is the first layer of insulation. Then within this first layer of insulation, inside there will be 3 wires: the line, the neutral, and the earthing wire. Each of these wires are again insulated a second time. So this is an example of a double insulated wire or circuitry.